this is a replication of one of Eric Dollard's, I guess, one of his first recorded experiments using the analog Tesla coil configuration, where you're transmitting through the dielectric instead of the electromagnetic. So yeah, it's some pretty interesting stuff. Eric Dollard was using an amplifier, but I'm just using a signal generator, and it really kind of messes with the output when I read the output, but I'll show you that anyway. But just keep in mind that it really, you'll see it when it happens, but it really dims the lights when you put the scope on it, and the frequency was really sensitive depending on the load. It'll have a harmonic, whatever it is, but you gotta find it. Okay, right now we've got 7.8 volts RMS square wave going in, 20 volts peak to peak. Just gonna unplug the and we got 20 volts peak to peak, 561 kilohertz. Okay. Here I actually measured what is it? I actually measured something like 555 kilohertz or something. So that's the actual frequency measured. You can see these landmarks where the lines fall. So it's a little bit less than what you're seeing on the screen. Okay, so we got all the lights lit up, and as you might know, 7 volts RMS with a square wave, it'll not light any of those. I'll show you that right now. So we'll take this off, put it up front, take that off, put it up front, and we've got no light. So, we can move down the line. Oh, we got something. Move it a little further. And they came alive. Keep going. And just kind of follows the trend. So I'll skip to the end here. Okay. So we've got all these lights lit up, and so we got this kind of odd stepping up effect through the one-to-one shunted coils. Something odd happened between here and there. Okay, and so now I'll take the scope and okay, so now just keep in mind that watch the light. Glitches my scope and it dims the light. So I'd say it dims it by at least 5 volts. Anyway, we'll read it as it is. got 27.2 volts RMS. 80 volts peak to peak. Where before we have 20 volts peak to peak. But peak to peak are ending up being RMS, which is actually 27.2 volts real power. Well, real voltage across the load. But keep in mind that when I connected fully across, the lights got dimmer, so we're actually reading the dim reading. So that's why I'm not going to complete the entire, power out and power in measurement, because I can't measure the output properly. It dims it by grabbing across it. So some pretty cool stuff. Eric Dollard was saying that it's an accelerating wave, and he measured basically if you take these four components, the two coils and the two caps, that's one phase, two phases, three phases, four phases, and this is an analog of the Tesla coil, and the easiest way to produce a longitudinal magnetodielectric wave as opposed to the standard